Hi, in this video we will do examples for finding equations of planes determined by 3 points. While find an equation in both forms, point normal and standard form, for a plane through 3 points P, Q, R. You have to always start from this point. I need a point. Well, we can choose P to be that point, and we need a normal vector n. Well, how do we find that normal vector? First, you have PQ and PR, then you form PQ directed line segment and PR directed line segment. Find their equivalent vectors. Equivalent vectors over there will be, well, Q minus P, and then R minus P. If you cross product these two, you will get a vector which is perpendicular to those ones, and we can use them as normal vectors. So basically the normal vector here can be Q minus P cross R minus P. Okay, nice. So let's do that then. Normal vector is going to be Q 2, negative 1, 1 minus P, negative 1, 2, 3. Cross it to R, 3, 1, negative 2 minus negative 1, 2, 3. And well, very nice. Here I get 2 minus negative 1 is 3. Negative 1 minus 2 is negative 3. And 1 minus 3 is negative 2. Cross it by 3 minus negative 1 is 4. 1 minus 2 is negative 1. And negative 2 minus 3 is negative 5. Well, we have two vectors, 3, negative 3, 2, and 4, negative 1, and negative 5. These we have to cross and find the a normal vector here. So ignore the first column. It will be determinant of negative 3, 2, negative 1, negative 5 minus, ignore the second column and find the determinant of remaining, which is 3, 2, 4, negative 5. And then ignore the last column and find the determinant of 3, negative 3, 4, and negative 1. This gives us negative 3 times negative 5, 15, minus negative 2. This is negative 3 times, this is negative 15, minus 8. And then 3 minus times negative 1, this is negative 3 plus 12. Now this is a huge number, but doesn't matter for us. So we get 17, 23, and then just 9. Okay, then standard, the point normal form. Is n dot x minus p equals to 0. So in this case we have 17, 23, 9 dot x is x, y, z always, minus p, the point we took negative 1, 2, 3. This needs to be equal to 0. And then the standard form we start always from this point, from this equation, nx and p, then perform the dot product. So 17, 23, and 9 dot x, y, and z equals to 17, 23, 9 dot -1, 2, and 3. And what does this give us? This gives us -17 plus 46 plus 27, and together this is 56. On the right hand side, then we have 17x plus 23y plus 9z equals to 56. That is the an equation in the standard form for the plane. Okay, how about this other one? We will follow exactly same steps. So n is q minus p cross r minus p. So in other words, 1, 4, 0 minus 2, -1, 1, cross it by 1, 1, -1, minus 2, -1, 1. And that gives us 1 minus 2 is -1, 4 minus -1 is 5, 0 minus 1 is -1, cross it by 1 minus 2 is -1, 1 minus -1 is 2, -1 minus 1 is -2. We have two equations. Then the cross product is given by these determinants. The middle one, you don't forget that negative sign, and then determinant. First one, ignore the first column. That gives us 5, -1, 2, -2. The second one, ignore the second column, -1, -1, -1, -2. For the third one, oops, ignore the third column, so it will be -1, 5, -1, 2. So this gives us -10 plus 2 minus 1 minus 1, and -2 plus 5. Well, just easy simplifications here. We get -8. Sorry, here this is -2 plus 2 minus -1 times -1, which gives us 2 minus 1. So this is -1, and this is 3. We found n, we have p, so we can write point normal. N dot x minus p equals to 0. N is -8, -1, 3 dot x, y, and z minus p is 2, -1, 1. This equal to 0. The standard form always start from this point, nx, n dot x equals to n dot p. Here we have a -8, -1, 3 dot xyz equals to -8, -1, 3 dot the point 2, -1, and 1. This gives us -8x minus y plus 3z equals to -16 plus 1 plus 3. negative 8x minus y plus 3z is negative 12. That is an equation for the plane in the standard form. So we did some examples. I hope that you enjoyed it and you learned something new.